Hello class, today we'll be going over database and my name is Brandon Lee. It's the fall semester of 2018, ISA 4220. We're just going to look at the overview here. First we're going to be talking about database and what is database. Then we're going to go into Linux, Postgres SQL, and their hardening recommendations. A database is a collection of information that is organized so that it can be easily accessed, managed, and updated. Data is organized into rows, columns, and tables, and it is indexed to make it easier to find relevant information. The data gets updated, expanded, and deleted as new information is added, and databases process workloads to create and update themselves, querying the data they contain and running applications against it. Postgres SQL is a general purpose and object relational database management system, the most advanced open source database system. Postgres SQL was developed based on Postgres 4.2 at Berkeley Computer Science Department and at the University of California. Postgres SQL was designed to run on Unix-like platforms. However, Postgres SQL was then also designed to be portable so that it can also run on various platforms such as Mac OS X, Windows, and Solaris. Postgres SQL is free and open source and is an open source software. Its source code is available under Postgres SQL license, a liberal open source license, and you are free to use, modify, and distribute Postgres SQL in any form. Postgres SQL requires very minimum maintain efforts because of its stability. Therefore, if you develop applications based on Postgres SQL, the total cost of ownership is low in comparison with other database management systems. Here we're going to talk about a couple of hardening recommendations for Postgres SQL. First, we have client authentication control. This is when installing Postgres SQL, a file named pg_hba.conf is created in the database cluster's data directory. This file controls client authentication. From the official Postgres SQL documentation, we can define the pg_hba.conf file set as as a set of records, one per line, where each record specifies a connection type, a client IP address, which is relevant for the connection type, a database name, a username, and the authentication method to be used for connections matching these parameters. The first record with a matching connection type, client address, requested database, and username is used to perform authentication. There are a lot of combinations you can make to refine the rules. The official documentation describes each option in detail and has some great examples. But remember to avoid rules that are too permissive, such as allowing access for lines using database all or address 0.0.0./0. For ensuring security, even if you are forgetting to add a rule, you can add the following row at the bottom. As the file is read from top to bottom to find matching rules, and this way you ensure that for allowing permission you will need to explicitly add the matching rule above. Next we have server configuration. There are some parameters of the Postgres SQL.conf that we can modify to enhance security. You can use a parameter listen_address to control which IPS will be allowed to connect to the server. Here's a good practice to allow connections only from the known IPS or your network, and avoid general values like 0.0.0.0, which will tell Postgres SQL to accept connection from any IP. Changing the port that Postgres SQL will listen on, which by default is 5432, is also an option. You can do this by modifying the value of the port parameters. Parameters such as work underscore mem, maintenance underscore work underscore mem, temp underscore buffer, max underscore prepared underscore transactions, and temp underscore file underscore limit are important to keep in mind in case you have a denial of service attack. These are statement session parameters that can be set at different levels on the database level, user, and session level, and managing these wisely can help us minimize the impact of an attack. Next, we have user and role management. The golden rule for security regarding user management is to grant users the minimum amount of access they need. Managing this is not always easy, and it can get really messy if not done well from the beginning. A good way of keeping the privileges under control is to use the role group user strategy. In PostgreSQL, everything is considered a role, but we are going to make some changes to this. In this strategy, you will create 3 different types or roles. First, there's role, which is identified by prefix r underscore. The next, group role, which is identified by prefix g underscore. And last, you have the user role, which is generally the personal or application names. The roles, which is r underscore roles, will be the ones having the privileges over the objects. The group roles, g underscore roles, will be granted with the r underscore roles, so they will be a collection of r underscore roles. And finally, the user roles will be granted with one or more group roles and will be the ones with the login privilege. Make sure to use specific users for different purposes, like specific app users or backup users, and limit the connections for that user only from the required IPS. Next, we have super user management. Maintaining a strong password policy is a must for keeping your databases safe and avoid the password hacks. For a strong policy, use preferentially special characters, numbers, uppercase and lowercase characters, and have at least 10 characters. There are also external authentication tools like LDAP or PAM that can help you ensure your password expiration and reuse policy. Also handle account locking on authentication errors. Next, we have data encryption on connection SSL. PostgreSQL has native support for using SSL connections to encrypt client-server communications for increased security. SSL, or Secure Socket Layers, is a standard security technology for establishing an encrypted link between a web server and a browser. This link ensures that all data passed between the web server and browsers remain private and integral. As PostgreSQL clients sends queries in plain text and data is also sent encrypted, it is vulnerable to network spoofing. You can enable SSL by setting the SSL parameter to on the PostgreSQL.conf. The server will listen for both normal and SSL connections on the same TCP port and will negotiate with any connecting client on whether to use SSL. By default, this is at the client's option, but you have the option to set up the server to require use of SSL for some or all connections using the pg_hba config file described above. Next, we're going to continue some of the hardening recommendation for PostgreSQL. First, we have, again, data encryption at rest. There are 2 basic kinds of encryptions, one-way and two-way. In one-way, you don't ever care about decrypting the data into readable form, but you just want to verify the user knows what the underlying secret text is. This is normally used for passwords. In two-way encryption, you want the ability to encrypt data as well as allow authorized users to decrypt it into a meaningful form. Data such as credit cards and SSNs would fall in this category. For one-way encryption, the crypt function packaged in pgcrypto provides an added level of security above the MD5 way. The reason is that MD5, you can tell who has the same password because there is no salt. In cryptography, a salt is a random data that is used as an additional input to a one-way function that hashes data, a password or passphrase. So all people with the same password will have the same encoded MD5 string. With crypt, they will be different. For data that you care about retrieving, you don't want to know the two pieces of information are the same, but you don't know that information, and you want only authorized users to be able to retrieve it. PG Crypto provides several ways of accomplishing this. Next we have logging. Postgres SQL provides a wide variety of config parameters for controlling what, when, and where to log. You can enable session connection, disconnections, long-running queries, temp file sizes, and so on. This can help you get a better knowledge of your workload in order to identify odd behaviors. For more detailed information on your workload, you can enable the PG_stat_statements module that provides a means for tracking execution statistics of all SQL statements executed by a server. There are some security tools that can ingest the data from this table and will generate an SQL whitelist in order to help you identify queries not following the expected patterns. Next, auditing. The Postgres SQL audit extension provides detailed session and/or object audit logging via the standard Postgres SQL logging facility. Basic statement logging can be provided by the standard logging facility with log_statement equals all. This is acceptable for monitoring and other usages, but does not provide the level of detail generally required for an audit. It is not enough to have a list of all the operations performed against the database. It must also be possible to find particular statements that are of interest to an auditor. The standard logging facility shows that the user requested, while PG audit focuses on the details of what happened while the database was satisfying the request. Next, patching. Make sure to check the Postgres SQL security information page regularly and frequently for critical security updates and patches. Keep in mind that OS or library security bugs can also lead to a database leak, so ensure you keeping the patching for these are up to date. Classic Control provides an operational report that gives you this information and will execute the patches and upgrades for you. Last, we have Know Your Workload. In addition to SQL standard privilege system available through Grant, tables can now have row security policies that strict on a per user basis, which rows can be returned by normal queries or inserted, updated, or deleted by data modification commands. The feature is also known as row level security. When row security is enabled on a table, all normal access to the table for selecting rows or modifying rows must be allowed by a row security policy. Here are my references, and thanks for listening.